Hi, all. So, welcome back to my series on memory management. And today, in this video, we are going to learn about the memory management techniques. So, basically, let's start the video with what are the various memory management techniques. So, basically, there are ways in which we can divide the memory management techniques. First is the contagious or contiguous, you can say. So whatever you spell, so this is contiguous memory management, and the other one is non contiguous memory management. So contiguous, please spell correctly. So first is contiguous memory allocation, memory management, and second is non-contiguous memory allocation. So in contiguous memory management, we'll see there are two kinds of memory management. First is fixed partition scheme, and the second one is variable partition scheme. So first is fixed partition scheme, second one is variable partition scheme. So this is a one way for managing the memory. The other one, non-contiguous memory allocation or management. In this, we are going to divide the memory management into various type. Like there is one type called paging. Another one is called multi-level paging. So this is also paging only, but a little bit different. We'll see in the further videos. And third is the inverted paging. Then is the segmentation or segmented paging. Okay, segmentation is one segmentation, and the last one is called segmented paging. Segmented paging. Okay, so these are the two groups in which memory management is divided: contiguous memory management and non contiguous memory management. Inside contiguous memory management, we have fixed partition scheme and variable partition scheme. And inside non contiguous memory allocation, we have paging. Then we have multi level paging, inverted paging, segmentation, and segmented paging. So, first of all, we'll see about contiguous contiguous memory management, in which we will see about fixed partition scheme, memory. Okay, memory management, it's two time memory. Okay, so contiguous memory management. So first of all, we'll see about fixed partition scheme. Now fixed partition scheme is the name only tells you about how we are going to partition the memory. Okay, so let's say we have a memory of 1000 kilobyte. So we are dividing the memory into a fixed slot. Okay, so we are dividing the memory into fixed partition, and that is why the term fixed partition schemes comes into picture. So in this partition scheme, memory is divided into fixed number of partition. Okay, in this partition scheme, memory divided into fixed partition. Okay, so what does this fixed partition means? That the size of each partition is gonna remain fixed. Okay, so let's say if it is 10 kilobyte, then this will also remain 10 kilobyte only. Okay, so in this way, that if the entire memory size is, let's say, 1000 kilobyte, so if we have to make a partition, we will divide it in equal. Okay, so in this partition scheme, memory is going to divide into fixed number of partition. So what does that mean, fixed number of partition? So if we have 1000 kilobyte of memory, okay, so we are dividing it into 10 10 kb. So let's say there will be 10 partition, or and it is going to remain the fix throughout. That means that it is not going to change. Once we have partitioned the memory into 1010 kb, then it is not going to change in the further future. Okay, so it's not about having this fixed partition that the size is gonna be 10 only. It can be 50, let's say. Just to clarify it, we'll see that let's say we have this memory chunk, and we have done the fixed partition onto this memory, and we have a certain partition. Let's say we have divided the memory into 8 partitions. So 4, 5, 6, 7. So it is 0, 1, 2, 3, 4, 5, 6, 7. So we have divided into 8 partition, and we have partitioned it unequally, but it is fixed. So let's say this is 50 kb of space. This is 150 kb of space. This is 200 kb of space. This is 300 kb of space. This is 250 kb of space. Then we have 70 kb of space. Then we have 120 kb of space. And then lastly, we have 220 kb of space. Don't go into the picture details. So it is just virtual. So these are the size of each partition. Now, fixed partition means when we are going to divide the memory, the partition size, that is, let's say this is 50 kb, this is 150 kb, it is gonna remain fixed throughout the process execution, throughout the program execution. This is not going to change. We are not going to change this partition. If it is it has been divided into 50 kb, it is going to remain the same throughout. Okay, so let's say if a process comes like P2, and this process requires 30 kb of space. So based on this, we will go and we'll assign this process to this first partition, and this will occupy let's say 30 kb space. Okay, so now this process has occupied 30 kb space in this partition. So what will happen of the 20 kb? It will remain unused. Okay, so this space is gonna remain unused. That 20 kb is gonna remain unused if we assign 30 kb of this 50 kb partition to this P2. So this is the problem with the fixed partition, that is there will be some kind of internal fragmentation always persisting in case of fixed partition. So fixed partition scheme comes with one problem of internal fragmentation. Internal fragmentation, that means if a process is assigned which is having less size than the partition size, then the remaining space remains unused. We can't assign it to any another process. Okay, because yeah, we can assign it. Let's say if another process comes P1 that requires 20 kb, then it can be assigned here. But it depends. If P1 comes up with not 20 kb, let's say P1 comes up with 220 kb. Okay, so now this 220 kb cannot be assigned into this space. It has to be assigned in again this 300 kb space. Okay, so in this way the partitioning of memory happens, and in fixed partition the partition size remains constant or fixed throughout. Okay, so this is the case of fixed partition. So now since we are clear with what are the benefits and disadvantages and advantages into it, so in every partition only one process can be accommodated. Okay, in every partition only one process can be accommodated. So if I have seen if I have told you that this P2 comes with 20 kb, then also it won't be assigned here. It has to be assigned in the next consecutive space if in fixed partition scheme. So if even if P2 can be uh, can be accommodated at this place, but yet we will keep this space as unused, and we will allocate this P2 into the next consecutive space or some other chunk. So it will occupy this 20 kb space. Okay, so This way, in every partition whatever we have done, we can accommodate only one process at the time. So this is one thing. And the next thing is degree of multiprogramming. Degree of multiprogramming is means number of processes that can be in a system for at one instant of time. That is called the degree of multiprogramming. So this degree of multiprogramming gets restricted with that, with the number of partition in the memory. So if we in one partition, uh, we are assigning one process at a time, then with the number of partition, if there are 10 partition, that then at a time we can have only 10 processes running. That is, a degree of multiprogramming gets restricted to the number of partition in the main memory. Okay, so this is another thing. And we can say that the maximum size of the process is also restricted by the size of maximum size of the partition. So maximum size of process is restricted by the maximum size of the partition. Okay, so if we have the maximum size of partition as 300, let's say, what is the maximum size of partition in this? It is 300, right? So the maximum size of process that can be accommodated here is of 300 kb only, not more than that, right? So let's say if a process comes here, and let's say the process p4 needs 350 kb space, so we cannot accommodate this process, okay, because we have the maximum partition size as 300 kb. Okay, so this is one problem with that. Okay, and we can't use the unused space, that is the internal fragmentation. So this is one case. And the second thing is every partition is associated with limit register. Okay, every partition is associated with limit register. Limit register is nothing but denoting the upper and a lower limit. So uh, we can say that for limit register we have one upper limit, that is the starting point of the partition, and there is one more called lower limit, that is the ending point of partition. So upper limit stands for starting point of partition, and this is the lower limit, that is the ending point of partition. Ending point of partition. So this is all about fixed size partition. So let's recall what we have seen. So in fixed size partition, we have divided the memory into fixed sorry, into fixed size of partition that is going to remain fixed. Even if a process comes with lower size, we can't use the remaining space here. Okay, so this leads to internal fragmentation, unused space, so it is a wastage of memory. And the max at one time only one process can be accommodated into each partition. So that is why the degree of multiprogramming gets restricted to the number of partitions in the memory, and maximum size of the process is restricted by the maximum size of partition, with each partition having fixed register denoting the upper and lower bound of each partition. Okay, so this is all about the fixed partition scheme, right? Next we are going to talk about the variable partition scheme, which is much flexible in contrast with the fixed partition scheme. Okay, so yeah, we'll see in the next lecture. So let's close it now, and thanks you very much for watching. Okay, thanks.